Howdy, welcome back to another episode of the Supply Chaney podcast. I am your host, Nathan Chaney, and this is a podcast where we dig into not just the professional stories that we kind of experience as being supply chain professionals, but also dig into a little bit just the people and the human side of that story as well. Today, we're going to talk specifically to a couple of folks that are in the material handling industry. Specifically, they are both members of the Conveyance and Sortation Systems industry group at MHI. MHI is the industry that makes supply chains work. And I think what we're going to get to talk about a little bit here today is what a lot of us don't see when we receive packages at home or go to a store and buy things. We don't exactly think about all the systems that it took to get those things where they are today to make it accessible for us as consumers. But us as supply chain professionals, we know there's something going on. There's a lot of magic that has to take place. So with that being said, I would love if Jeff, if you could take a minute or two to give people a quick introduction to yourself.
Yeah. So my name's Jeff Ashachik. I've been in the material handling industry for just over 12 years now, which seems like a long time for me. But I started off on the integrator side. I moved to a customer for a while, and now I'm back on the integrator side at Logistic as a senior systems design manager. I've worked on the design side is kind of where I started, worked on the deployment side, field installations, qualification, that kind of thing. And then I moved back into the design side from like a firm engineering standpoint, a little further up into concept development. And now my current role is actually owning from concept all the way through firm engineering. So.
Excellent. Well, thank you for joining in. I'm looking forward to unpacking some of your experience and your perspectives. Andrew, how about yourself?
I've been in the industry for just about 20 years. I started right out of college. Actually, originally wanted to do roller coaster design, and this to me is roller coaster design just for packages instead of people. But I started on as a project engineer doing implementation and the fine detail drawings, going on site, validating that what's installed matches what we designed. And then through the years worked closer to the pre-sale side to do high level concepting, coming up with new designs, trying to problem solve customer solutions, those types of things.
Okay. All right. I like it. I want to dig in more to that roller coaster design attempt here in a little bit. But first, Jeff, tell us a little bit about you, about Jeff the person. Where did you grow up? What was growing up like? And kind of what were you thinking when you were thinking you wanted to go be a mechanical engineer and go do cool stuff as an adult one day?
Yeah, so I grew up in New Jersey. I live in Raleigh now. Actually, in December, I passed the halfway mark, so I've now lived in the South longer than I lived in the North.
Okay, welcome.
I think I'm welcomed officially now. But yeah, I grew up with two brothers, really big into sports and some off-the-wall hobbies like juggling. I was on a TV show for doing two things at once. It was like a contest for juggling.
Okay.
Snowboarding, tennis, soccer, baseball, swim, pretty much doing something all the time.
I like it.
It was eventful for sure. But yeah, then I moved to the South. I went to Georgia Tech for mechanical engineering. Kind of knew that I always wanted to be an engineer. My dad was an electrical engineer.
Okay.
My mom likes to tell some story. When I was really little, I picked up like a pumpkin at Halloween that was lighting up, and I was like, "How does it work?" And my mom showed me the switch to turn it on and off, and I was like, "No, but like, how does it work?" And she said she just put me down, and she was like, "Oh my God, this is another one of them." So we kind of knew from a young age, but yeah, Georgia Tech was fun. I really liked the fact that it's mainly an engineering school, right? So there's all kinds of different engineers that are there. So you've got a mechanical guy who's friends with a controls guy who's friends with an electrical guy, and everyone gets together and comes up with really cool stuff. First job out of college was actually in manufacturing, which I don't know the actual percentage, but a huge number of mechanical engineers start in manufacturing, and kind of got into capital projects while I was there. So that was designing production lines, modifying production lines. Money kind of dried up there, but I was really interested in the project aspect and the design aspect of those capital projects. And that's when I kind of got recruited into the MHE industry, which was really cool to me at the time. And what I tell newer engineers coming into the industry now is that like conveyors are simple, right? It's a drive, it's two tails, it's a belt. So you're playing with very simple Lego blocks. The cool stuff is how complicated we can make it and how optimized everything is and all of the different configurations and how to solve different problems. What I really enjoy working with on the design side is when something is inefficient from a design side, but it's efficient for the operational use case. And those are really fun because you look at it on paper and you're like, this doesn't make any sense at all. And then the customer's like, no, that's what I want. So it's really cool. There's a lot of new stuff. There's a lot of evolution in the industry, which is really cool, both from like an equipment standpoint and an operational standpoint, and just like the overall impact of the larger industry of how are you receiving products? How are you sending them out? What time frame are you sending them out? Is it a constant or do you have to hit a specific window? All of that is like being pushed to different limits on different like warehousing operations. And so the fact that it can be broken down to a very simple piece to solve a complex problem. And that's what kind of keeps me interested and excited about work.
You know, I like to tell people the base word of logistics is logic. And so, and I like how you simplify that even more by just saying it's basically just playing with Legos. And that really kind of helps
I was
put it in
quite
perspective.
into Legos as a little kid as well. So I'm thinking that's pretty popular within the industry.
All right, Andrew. Well, your turn up to bat here. Tell me about your kind of, where you're from, what you were like growing up, or were you the nerd in the class that was getting straight A's, or were you the troublemaker or the comedian? What's your archetype?
I was a little bit of both. I was actually a band geek, so I enjoyed music. I played the drums, made lots of noise, but I was a similar upbringing of I played with Legos, played with Kinects, built everything that I possibly could, did all kinds of systems. And then my caveat was I always took things apart. So to figure out how they work, I would physically take the screws out of things, look at the wiring, and then attempt to put it back together. And that didn't always work when I broke the remote to the TV, broke my alarm clock, broke the flip phone that I had in high school. But, I figured out how it worked. I just couldn't put it back together. And so I ended up going to the University of Cincinnati for mechanical engineering so I could learn how to put it back together. Went through, and thankfully they had a co-op program. So it was a 5-year degree, but for 4 of the years you would go to school and then do co-op. And so the co-op allowed me to get into the industry and work part-time, full-time, depending on the quarters, to figure out designs, come up with drawings. And back then, 20 plus years ago, it was 2D drawings, and it was the fun part of you lay everything out and then you'd have to draw a side elevation, with construction lines off to the side. It was very time consuming, but it was a great way to learn the industry and learn what things could do and how things worked. And then, transition through project engineering, going onto site, figuring out how the system would actually be implemented, figure out how they could make sure installation was complete, and, eventually just keep shifting to come up with concepts and figure out how to solve customer problems before it gets to the installation side.
Let's back up a little bit more. Where are you from? What was family life like growing up, and those sort of things?
I'm from Northwest Ohio, Bowling Green, Ohio. Grew up there. I have 2 older sisters. We went on trips and traveled a lot, but they are a lot older than me, so they did their own things, and I was just kind of I was off to run by myself. Played golf a lot. My dad was an avid golfer, and so I grew up on the course. I worked at a golf course all through high school, pulling out carts in the morning, putting them away at night before I could even physically work for pay. And then once I could actually work for real, I worked in the pro shop and learned how to build clubs, change out grips, do all the work that you did, everything besides the actual maintenance of the course.
Yeah, we were just talking, before we started here about golf and the Masters coming up, and you said that you played a little. Now I understand you know your way around a course, literally. So excellent. Well, thanks for both of you all taking some time to join me and kind of just educate and inform folks on what a career looks like, right, as a mechanical engineer in the material handling industry. Let's dive into that a little bit more before we kind of talk about a little bit more of the nuts and bolts. So Jeff, you described going, to Georgia Tech, and that you kind of knew you were on this path to be a mechanical engineer. Can you, for those that are business folks, and now that you've kind of got a business hat on as well, being a manager, can you reflect on kind of what you learned and how you're applying that today, and maybe what they didn't teach you in school that you are kind of picking up on the job over these years.
Yeah, a lot of what they explained while we were in school and what I heard from mentors new in the industry was that engineering school, they teach you how to think, right? They don't teach you how, like, no one's going to teach you how to do this job. Sure, there's intros to AutoCAD and SolidWorks and all of that fun stuff, and it's really theoretical modeling and math and physics and that side of things. It was really fun to use some kinematic equations as part of a recent project. And so it was nice to break out the old physics books and get into that. But a lot of why I chose Georgia Tech too was because, similar to the upbringing of always being in sports and being part of team sports and stuff, is they were really big on different events. Like there was robot competitions and things that we were part of. There was we won like a catapult building contest at one point. That was fun. And the amount of like intramurals and club sports and things like that, it really teaches the teamwork aspect of it, which is not like, okay, I'm a really good engineer, I can figure all this stuff out. But getting into the industry and actually doing this, and like these projects have so many different stakeholders with so many different backgrounds, but being able to think as an engineer and work with others and be able to communicate complex stuff to like a simpler form so that everyone involved in the project knows what's going on. I think that was a really big piece that kind of allows you to be successful further on in the industry.
Yeah. Yeah, I saw club volleyball there on your list of things, and my son right now is, I'll just say he's picking up basketball. He plays a lot of basketball, and even whether he scores 0 points or 20 points in a game, as a parent, I'm thinking this is teaching him teamwork skills and the ability to work with others. And to your point, Jeff, when you get out in kind of the real world, nobody's like a solo operator. Everyone's kind of working with other stakeholders, and so being able to treat life as a team sport of sorts is I think a critical skill. On your side, Andrew, you spent a good amount of time at Intelligrated and Honeywell. Can you kind of just talk about what that progression looked like? And going through a few different roles and promotions there, I guess, during that career there.
Yeah, so I started out co-oping, obviously, and just doing grunt work, printing pages, sending them out, doing everything that was basically asked of you. And I eventually worked into leading projects. My first project was with Amazon, and so figuring out how to do that and the requirements that were around that. And then the projects just continued to get bigger and bigger and bigger. Eventually went into a program role, and so every single project under a customer would be run by me, figure out all the different specs that are required, all the different requirements. That was the biggest one, because every single year there continued to be more and newer specs to be able to come up with and follow. And then eventually shifted into the pre-sale side of solving the problems, and that was the biggest one, of the way that you have to look at something and the speed that you have to respond to it is the biggest change, because concepting isn't detail oriented. Ideally, you don't talk about speeds at all. You just come up with a new layout, figure out what works, make sure you have the right building blocks and Legos in the way. You have to have gapping belts, staging belts, accumulation. You have to have the right products and conveyor to handle what needs to happen. But the pre-sale side is also, to me, the most fun, because problem solving and coming up with those solutions is the best part. And so the detail side is great for learning. So if new engineers coming out of college, learning how to do a system, it's great to go through those levels, but the quicker you can do it, the faster you shift to the pre-sale side, basically.
Gotcha.
To say I was definitely part of the ever-changing specifications and customer requirements. That's where Andrew and I first overlapped almost 10 years ago now. Was my first solo project at Amazon through the engineering phase, and it was slightly different than what Intelligrated had delivered in the past. So there was a lot of like unique, nuancy stuff that we figured out together on that first project.
Okay. Can you say more about this? What other sort of details can you share about the project, I guess, itself, and how you and Andrew interacted?
Yeah, so from Amazon side, it was their first real ground hub. Is the biggest one that we had done up until then. At the start, there were 4 inbound shoe sorters, got reduced down to 3. 18,000 packages per hour each. And then there were 3 outbound sorters, 18,000 packages each. A 4th was later added on, and then a small sort that was 20,000 packages per hour. So it was pretty large site, pretty complex, but the individual subsystems are conceptually duplicates of each other, right? So you've got like bulk handling coming in, going through a singulator, going into a shoe sorter, then going into a collector, then going into a singulator, then going to a shoe sorter. So it's using the Legos to build this subsystem, and then using these subsystems to duplicate and build a larger system. And so a lot of those concepts were familiar to Andrew and to Intelligrated, but the way that we wanted them kind of integrated with each other was the unique piece.
The way you wanted them integrated, you mean? So, Andrew, tell me a little bit about being on the other side of that coin of that project. Well, I think I heard some change orders and requests and kind of just being a little bit fuzzy.
Yeah, that happens on every project. Every time that, there's change in the field, you always have to have the change order. But the biggest thing was every time we tried to concept things, we would, hey, come up with this new design, and during the design, it would be, well, we can't do that because of this specification, or we can't do that because of some other specification. So a lot of the lessons learned out of that project was creating a whole new specification of why it needed to be a certain way, how it needed to be. And it was a great time that we worked together to make sure that what Amazon was writing for their specifications, we could follow as a vendor as well, because they have their own rules and safety and guidelines, but you want to make sure that the conveyor vendors can even provide that rather than create a specification that can't happen.
One thing that I notice, Andrew, in your profile here is that you have an MBA as well. And one thing I like to tell people is like the most dangerous person on earth is a mechanical engineer with an MBA. To be honest, I wanted to be an engineer myself. I wanted to be a mechanical engineer myself. I thought the math would be too hard, so I went business school route instead. But anyway, can you talk a little bit about the, kind of like the business kind of school experience and viewing that from an engineer's perspective and how that's impacted your career?
So it impacted in the fact that I understand why decisions are made from like a leadership and a corporate level. A lot of the time as an engineer, you're in the weeds trying to figure things out, and you're like, why can't we do it this way? Or why can't we come up with this solution? And there's always a reason for it, whether it be the cost of doing things manufacturing wise, what the high level costs are, trying to come up with changing conveyor systems, why we don't have, 2-inch center rollers on some things as opposed to the 3-inch center. And it costs that much more to manufacture that part as opposed to just changing the way that the labor's done or changing the way that the manufacturing lines are figured out. So there's a lot more that goes into it from a operational cost. But the reason that I went back for an MBA was literally boredom during the pandemic. I was working and my wife decided to go back to school and become a nurse because she wanted to have a job that was always going to be there, which nursing always is, definitely through a pandemic. And so while working full time, I basically took night classes and got my MBA over, I think it was 16 months, 14 months. And so it was every single night from, 9 o'clock to midnight, 8 o'clock to 11, somewhere in there. Basically, I was taking courses online, doing different things to make sure I could get through it all as quickly as possible.
Wow. Kudos to you. I took like 6 years to get my MBA. I went on the very, very slow scenic path. So congrats to you knocking that out. Kind of pivoting over onto your side, Jeff, I see that you've been kind of in a manager type of role for a number of years. And there's a difference between being an engineer, I guess, and kind of doing the things versus managing engineers. Can you kind of talk about kind of the difference between those roles and kind of how you look at it?
Huge difference. That was a massive learning curve because being a good engineer, it doesn't translate to being a good manager, right? It's a completely different skill set, and managing engineers is a different skill set by itself. I, coming from the engineering background and knowing what's important to people and how they think and what's going on, definitely helped me grow into that management side, because being able to communicate things or explain like why things are going on and what's going on, I guess I I better understood of what they were looking for, not just like, here's the new direction, here's what's going on, but here's why it's going on and here's how it affects you. So it's been like an incremental from whatever it is, like 3 people, 2 people, 6 people, 9 people, 12 people, all gets very different along the way. And I still think the team aspect of it is really exciting. And when people would explain to me like the whole force multiplier cliche, I don't like when cliches are correct, but seeing it in action is really cool to work with different people, know their strengths, be able to like set them on their path and let them run loose. And then looking at like my impact and how that can multiply to a program, to multiple customers and multiple deliveries is really cool to see and to enjoy. Like when the whole team is operating on all cylinders and hitting deadlines and doing things and the morale is high, it's really cool to see everything come together as a team and to see engineers like come out of their shell and continue on that path and get in that teamwork and everyone's excited and talking to each other and like coming out of their silo is really cool to see and be part of. It comes down to like same kind of thing like growing up is like I was always say the organizer of putting like a wiffle ball league together, but like getting everyone there and seeing the vision come to light is has been cool.
Awesome. Can we talk a bit about, you started to kind of touch on the company there and some of the elements. Can you touch on a little bit on Logistic and like just the company's story? I think it's got a pretty long history.
Yeah. So Logistic, we officially are our own company now as of January 1st. We used to be part of Luco. Luco's been around for 100 plus years, a little over 100 years. And I mean, they started out as a welding company. So whatever was needed at the time, like, cool, we can build it. We're fabricators, like, let's go. That kind of, we actually joke internally. There's pictures, old pictures from a trade show where we actually built a conveyor that was for, it's like a treadmill for a horse. So they were at horse shows to keep the horses moving. And so we joke about that internally, but they got into roller conveyors, getting into powered conveyors, belted, not belted, etc., like all kinds of different industries and use cases, like high temperature applications and stuff like that too. More recently, we then kind of took that manufacturing side and are working now into the integration side. So we work with all the big customers in the industry, and we're building out. The reason that I came here is to build out that integration piece, and so we're getting year after year. I mean, it seems like month after month is just like the next. Every new project that comes in is the new biggest project that we've done. So we're in like a really high growth phase right now, which is cool. So we've got a bunch of new people coming in, a bunch of cool new products being developed, and then this year at Modex is going to be like, I feel like everybody, all of the customers that we bring into our office and show them what we have to offer, a lot of the response is, oh, I didn't know you guys did this. I didn't know you guys did this. So Modex is going to be really cool to kind of like showcase everything that we're doing, what we're capable of. There's all kinds of like the conveyor design stuff, the supply stuff of new equipment. We recently had a large parcel simulator being qualified with some larger customers. So we got that going. We've got simulation capabilities, all kinds of cool stuff that we're really like ramped up and ready to get going on.
Awesome. Let's kick things over onto your side a little bit here. Question for you, Andrew. Who is with you and Jeff kind of both representing integrators? I'm curious, what is kind of the ideal customer profile, for you there at DCS, and maybe just for you personally?
So a lot of people like a customer that knows what they want. I would prefer one that doesn't know what they want. Having an idea of what they need or understanding their operations helps bring a lot more value to come up with new designs or come up with new solutions. Like, they have a problem that they will ultimately want to solve, but I want to show them different ways to solve it. So it's not always, just put it in a shoe sorter, put it in a singulator. Like, it's not as simple as that. I want to come up with the best value for what they're trying to do, but also be the most flexible because things are going to change in the future. How they do their operations, what their throughputs are going to be, all that's going to change depending on how they grow their business. So I want the solution to be able to grow with them as opposed to just solve what their issue is today.
Is there any type of like industry vertical or like type of customer or whatnot that you all kind of target there at DCS?
There isn't. We do both parcel with, shipping companies and also DNF buildings. We get into other areas as well, but it's everybody in their, anything that can be done with conveyor, we will try and, work with and try and problem solve.
I see. Gotcha. I want to kind of zoom out a little bit here. And one question, Jeff, you've said that you kind of started in manufacturing, and that's a place that a lot of mechanical engineers kind of get their start. And that didn't pan out for you long term, which is why you kind of ended up where the path that you're on. There's been a big push here in the last years to bring manufacturing back to the U.S. And I realize you've maybe had like a third row seat to that over your career, but I'm kind of curious about your thoughts about manufacturing in the U.S. and kind of like just your perspectives on it.
Yeah, that was a big reason why I came to Logistic as well. It's because all of our manufacturing is here. We're based in Port Clinton, Ohio. It's even led to additional business for us with tariff craziness going on. Like we've had integrators who manufacture internationally that haven't been able to get equipment to the U.S. quickly enough to get installs, and they tap us to be able to make that in a pinch and deliver it. So it's been a real advantage for us for sure. And also like keeping it close by. There's a lot of R&D that's done, and it's real easy to walk out of my office, walk into the plant, look at what's going on. Like, hey, how are we doing this? What tools do we have? Like, what other processes can we do? Like, cool. All right, let's go with this. Like we've got manufacturing engineers and people that are in there that are helpful. I think what it really helps with on the customer side is that you've got manufacturing, right? And they know manufacturing, but they know how to manufacture what we're looking for. But if the customer is looking for something different, again, that might not be efficient from the manufacturing side, it's our job on the system side to explain like, hey, here's what the customer is looking for. I know that doesn't make sense with how we're going to build it, but this is how they want it. And so knowing the industry and knowing the customers and then being so close with manufacturing really helps bridge that so that we're actually producing a product that's like desirable by the customers.
This kind of goes to what you were saying earlier, Andrew, about like you like a customer that you can present and get creative and present some options to them. Over your time of kind of doing what you're doing, what's the state of technology now, I guess? What are the kinds of tools? Is there any AI being used to help do some of that pre-sale work?
We're definitely using it, trying to do data analysis and figure out from pricing standpoint, those types of things. We aren't using it yet for drawings, but I'm sure that is coming because there's definitely a lot of programs that are trying to decide and figure out what conveyors can be put in what order. And so it'll definitely continue to go to that.
I've always got to ask that AI question. How about you there on your side of the aisle, Jeff?
Yeah, same kind of thing. We're exploring a couple different use cases. One of the ones that Andrew mentioned earlier, like having multiple spec documents, multiple versions and requirements within groups of the same customer, and then between customers, being able to quickly review, say, requests for proposals, look at specifications, be able to see where there's conflicts and things like that. It's all really, really easy to help with stuff like that. The other thing that we're looking into that Andrew mentioned too is if we've got a 3D model, it's got to go through internal checks before it goes on to the next step, right? Like, is this support in the right spot? Does it need to move? Like, is this the right horsepower? Like, all of these basic checks that kind of go through, all of that we're looking at bringing AI in to be like, hey, here's your AutoCAD model. Here's what your rules are. Let's do like a quick check. Are we compliant in all of this? Like highlight where we're not compliant, and then we'll focus our actual engineering effort on solving those problems. So there's definitely some use cases for sure, which speeds up a lot of what we're doing. And as a growing small integrator, again, these stupid cliches that keep being right. It's like it allows you to do more with less, right? Like we don't have a huge engineering department with resources that can be doing that stuff. So the more tools and the more efficiency that we bring, the faster we can scale and get up to the next level.
As we kind of wrap things up here, I would kind of like to get some forward-looking perspectives from each of you of just kind of what you see coming down the pipeline, what's exciting and interesting, coming up here, kind of just in the material handling industry, but also specifically, in conveyors and integration. And I'll let you go first, Andrew.
I really like seeing all the new equipment and the new designs that are coming out, seeing different ways that you can handle the product, different ways that we can sort product. I mean, there's definitely the shoe sorter's older than old. So coming up with something different or something that can, do comparative speeds, but handle it in a different way is always going to be fun and different. The most recent things that I've seen at ProMat and Modex is, there's right angle transfers and the omni wheel diverts and different ways that you can singulate the product or move the product, but it's all contained in a single unit. And so being able to handle the product that way is fun and different.
All right. How about on your end, Jeff?
Yeah, kind of along the same lines. A lot of new vision-based stuff is cool. As packaging evolves, you get different types of poly bags, like large stuff like bicycles and things like that want to be shipped. So your use case is constantly changing, and so seeing different equipment that can, like, okay, now am I going to design a conveyor that can handle a refrigerator? Like, probably, I got to now. So seeing like the use cases are what's driving the technology improvements. Same thing with operations. If you need like a longer buffer inside the building versus keeping stuff in a trailer and only unloading when you're ready to process. Mm-hmm. So as operations evolve, as like customer use cases evolve, the more and more different stuff that we start handling, hazmat stuff, all of that is driving like cool improvements. And then it also still comes down to like the ground level physics of like, can I handle this on a roller? I need 3 points of contact of this box on a roller, like no matter how I'm sorting it or handling it. So like the fact that it all comes down to those basic building blocks is really cool.
It seems like, yeah, everything just comes right back to building blocks, aka Legos. That's my big takeaway from this conversation.
I mean, physics is the limitation, really.
Well, hey, I appreciate both of you coming on and spending some time sharing your stories and your experience, your insights with myself and with the audience today. Looking forward to maybe bumping into you all at Modex here coming up soon.
Sounds great.
Yeah, sounds great. Thanks for having us.